Hello everyone, welcome to a new video on electric vehicle technology. In today's video, we are going to discuss about a case study on roadway mechanics impact on EV performance. Now, there is a huge proportionality between roadway mechanics with EV performance. So we have a group of students who have come up with a case study in which they are dealing with a company which has faced a problem with this roadway mechanics, and they come up with a solution also. So let's see what they are going to discuss, and let's discuss how they come up with the solution.
Electric vehicles are becoming an important part of modern transportation because they reduce air pollution for dependence on only fossil fuel. Many countries, including India, are promoting EV adoption. However, the performance of EVs does not only battery and does not depend only on battery and motors. Road missions such as road conditions, slope and rolling resistance. In cities with poor road condition, EVs may depends energy and so reduce railways.
So, what is the case study that you are going to discuss today?
So the case study I'm going to talk about is Indian road mechanics. So recently a lot of companies from India, basically railway companies, are using EV vehicles such as Tata Nexon EV for daily logistics and transportation. So they use this EV for betterment of IC engines. So according to the manufacturer, the EV vehicles could produce 300 kilometers per charge, but in a real-time application, for example, in urban cities, these EVs can produce at a maximum of 250 kilometers per charge. This is due to the road conditions like pitfalls, frequent pitfalls, and frequent speed breaks. So, after a lot of investigation, the crew came out with the idea to find the betterment of EV.
So actually, this is the case study that we are going to discuss today. So how these manufacturing companies are facing a reduced EV performance because of poor road conditions. So before getting into the case study deeper, let us discuss what are the factors that affects the EV performance with regards to the roadway mechanics.
Several factors can affect the EV electric vehicles. The first one is rolling resistance. Rolling resistance is the force resisting the motion of the tires when roll on a surface. The second one is road gradient. When the vehicle moves uphill, the electric motor produces more torque, which requires high energy from the batteries. And third one is surface roughness. Uneven creates vibrations and backwards, which increases the mechanical losses in the motor.
So the factors mainly concerned are rolling resistance and road gradients and all. So what problem these manufacturing companies face with these roadway factors?
Due to these road mechanics factors, several problems are observed in the EV fleet. The driving range were reduced by about 20%. The electric motor experiences higher thermal stress, and the suspension component requires higher mechanical stress. The vehicle require more and frequent charging. This increases the cost and maintenance of the company.
So what would be the solution for this problem?
To solve this problem, engineering implements several solutions. Regenerative braking. This system converts kinetic energy during braking into electrical energy, store it back in the battery. Rolling resistant tire. Special EV tire reduce friction between tires and road surface. Special suspension system. Improving the suspension system reduce the vibration and improve the vehicle efficiency.
After implementing these solutions, the company observed several improvements. Driving range increased by 15%, motor temperature reduced significantly, increased, charging frequency also reduced, and tire life increased due to increase in traction. This case study shows that road mechanics plays a very important role in EV enhancement. By combining better vehicle design, intelligent software systems, and better road infrastructure, vehicles can operate more efficiently. In the future, improvements in smart transportation will further enhance EV performance and sustainability.
So, thanks for the conclusion. So, we come up with a good case study in which we discussed why this road mechanics plays a vital role in EV performance, how it reduces the EV performance, and what are the solutions the manufacturers made in their perspective. It is not like repairing the road and making it smooth for good driving. It also depends on making a good change in the EV design also. So there is a compromise between the EV design with the road mechanics that will give a good performance increase in for the users. Okay. So thank you for participating in this case study discussion. Hope we meet in a new topic. Thank you.